All right, hello everyone. This is the last video I'm going to do for the binge I've been doing for right now. But basically, this is the solutions for lesson 5. For questions 1 to 3, I'm going to provide a scenario. This is from the video of the roller coaster you should have saw, and you just have to explain how the LL diagram will look like. So basically, what will have like the most energy, what will have the least energy, and so forth. So we can, and also we're assuming there's no friction in the roller coaster. So for this, we have the roller coaster on top of the ramp. So technically, at this point, the roller coaster is moving. So the roller coaster is moving slowly. So there is a small amount of kinetic energy. Since there's a large height, there is a large amount of potential energy. Nothing to do. Just basically which one's big, which one's low, and is there anything else? No. If there's no other energy, you don't want to list it. Right? So that's all for here. Now for number 2, there's a roller coaster at the bottom of the ramp after they fell down. And now you can see there's a lot of kinetic energy and very little potential energy. So this is the opposite. Now the cart is moving fast. So there is a small amount of kinetic energy. I mean, not a small amount, a large amount of kinetic energy. And the cart is low from the ground. So there's a small amount of potential energy. So if we were to make a graph, you're going to have the KE be high and the PE just be very low comparatively. I'll try to do it for this. Let's do 3. This time they're at the middle, the roller coaster is in the middle between the ramp, the middle between like raising up towards the ramp. So like the middle between that. So what does that mean? Well, it still has a speed from the bottom, so it's kind of slowing down, but it also has a more height, which so it's slowing down and getting higher. So we don't know for certain, but in this case, it's like in the middle of it, we're going to assume that the PE and KE are equal. It still has movement to form kinetic energy, and it's not very high up, but not very low either, but still has a decent amount of potential energy. So that's what we do for 1 to 3. 4 through 6, these are the problems you should really pay attention to, because this problem is honestly harder than most of the quiz that you're going to get. Well, for 1 to 3, the level 3 questions. The level 4 question might be a little bit harder, but it's not that hard comparatively. But basically, if you know how to do this, you'll know how to do the quiz. So I'll give you these 2 scenarios, and actually their quiz will be similar to this, where I'll give you 2 scenarios and then analyzing the energies. So the roller coaster has a mass of 100 kilograms and moves at 30 meters per second. The height is 10 meters above the ground in both the initial and final cases. So right here, 10 meters above the ground, right here, 10 meters above the ground. In the final case, the spring completely stops the cart, and we're going to assume gravity is 10 meters per second. Okay. Right. So this is a minor change I made from the handout I gave you. The handout I put 9.8, but this one I actually put 10 because, little hint, I'm going to make G be 10 in the quiz. Okay. So I gave you the equations for kinetic energy and potential energy, 1/2 mv squared, potential energy mgh. I didn't give you for a spring, but you'll see why I didn't, because you don't need it. So first part, like for this, it's gonna be like a quiz, keep track of your answers so you can make the graphs for 5 and 6, because 5 and 6 is where you're gonna do the LOL diagrams. So first part, A, name the parts of the system. So let me do that here because I'm gonna start doing these problems here. Let me see. So this is 4. Now we're gonna do A. So the parts of the system of the roller coaster, in this scenario, there's the cart, the earth for the gravity, the track, and then this time the spring. Because the spring is what stops the coaster. So the parts are the cart, the earth, the tracks, and the spring. Okay. All right. B, calculate the kinetic energy in an initial case. So I only said initial case because I said in the final case it completely stops. That means it does not move. There's no kinetic energy here when it stops, only here when it moves. So let's do that. So KEI equals 1/2 mv squared. And we have M right here, 100 kilograms and moves at 30 meters per second. So that's your V. Okay. So based on the problem, M equals 100 and V equals 30. Just making sure. So KEI equals 1/2 100 times 30 squared. Do this math. 1/2 100 and 30 squared is 900. If you do that, you should get 45,000 joules. 100 times 900 is 90,000 divided by 2, 45,000. Okay, so that's the initial kinetic energy. C. C says calculate the gravitational potential energy for the initial and final case. So both initially and final, right here and here. And they're both the same. I give you this hint because the height does not change, the gravity does not change, the mass doesn't change. So they're going to be the same number for both cases for gravitational potential energy. Okay, so let me calculate that. MGH, I said the height was 10 meters and still the same M. So PEG in general is MGH. We have M equals 100. HI, or the initial case, high, is 10 meters, but also HF, the final height, is also 10 meters. So that means PEGI is going to be the same thing as PEGF. So whatever number we have for PEGI is going to be the same thing for PEGF. So that's going to equal to MGH, so 100 times 10. I said G is 10. Let me write that up here so you don't forget. Meter per second squared, that's just the units, times 10 again. So that's going to give you 10,000 joules. Let me do it without the comma that big. So that's the potential energy in the final case and the initial case. All right. Do a new page for this. Okay. Determine how much elastic potential energy there should be if energy is conserved, and you know what the energies are in the initial case. Sorry, that's a typo. I'll try to make sure I don't have typos for the quiz. So this, we need the conservation of energy equation. So now doing See? So we got to make sure that EI equals EF. So first, what do we know what's in EI? We have kinetic energy, because it's moving, and we have gravitational potential energy. So I'll write it down. Kinetic and gravitational potential. In initial case. At the end. Right. Let's write our steps for EF. That's really ugly. I'm gonna try to do these slower so they don't look as sloppy. So what do we have? Should not be an equal sign. That should be a colon. For here, we don't have kinetic energy because it's not moving. So we have P, again, the gravity, this time final, but also potential energy for the spring or the elastic potential energy. So I can put that with an S, final. So right down here, we have gravitational and elastic or spring potential energy in a final case. So let's take a look at the diagram so you can see that. I said the first case only has kinetic and gravitational potential. We can take a look at the picture. Yeah, there's only gravity and it's moving. That's it. The final case, I said gravitational potential and elastic energy. So there's only the height it has from gravity, and then the elastic, the spring energy, potential energy. It's not moving, so there's no kinetic energy. So we gotta make sure that these two numbers match. So our value for EI needs to equal EF. So let me write that again. So we have 3 numbers and 1 unknown, so we can solve for that. I'll do this in below. So the equation would be what we know EI, KEI plus PE, potential energy of gravity, I, equals, and in the final case, again, potential energy of gravity plus potential energy of the spring or the elastic potential. Let's start plugging in. We said this was 45,000. This was 10,000 equals, again, PEGF is 10,000 potential energy at the final case. The potential energy of the spring in the final case, we don't know what that is. So that's what we're going to solve for. In fact, let me do that a different color. So for this, we will solve for it. right, so let's solve this. 45,000 plus 10,000, that's 46,000, or 55,000, sorry, equals 10,000 plus PEACF. What we do here, just basic math, subtract 10,000 to both sides, add. Just solve for it. That means 45,000 must be what our gravitational elastic energy is for the final case. Sorry about this. You know what, I'm not gonna box it, I'm just gonna leave it there. That's our answer. Okay. So 45,000 joules is our answer. So that goes to D. All right. Now we're gonna do the first part of the first L of the LL diagram. So the initial case, we said there was only kinetic and potential. And we calculated kinetic for the potential energy, and that's gonna be 45,000. So we're just gonna fill this table out. In the first case, there's no spring, so this should go to 0. And we calculate kinetic energy to be 45,000, so you should put that at 45,000 down there. And this should be 10,000, because that's where we calculated the potential energy to be for gravity. So that'll be your graph. And then the final case. For this, there's no kinetic energy, it's not moving, it's completely stopped. The gravity is still 10,000, and then we calculated it, and it's actually the same thing, 45,000. Remember energy in the beginning, which was 55,000, energy at the end, you can check, it's also 55,000. So those are the graphs. So for the quiz, just make sure you know how to set up these graphs. Just practice with these assignments about dragging it and then putting it to the right place. And then just know how to do, you know what, I'll actually write it down here. Specifically, know how to calculate KE. As 1/2 mv squared. Don't forget squared. And know how to calculate gravity potential as mgh, m times g times h. These are all multiplication. There's no addition, subtraction, or division involved when you're just solving it like this. So know these two equations, know how to do this, initial energy and final energy, and what goes in there. So like if there's only potential energy, you'll put PEI. And if there's kinetic and thermal energy, you'll put it here, KEF plus TEF. So, but if there's no thermal energy, you can just take that off, it's just those two. You only put what you see in that system. And just know how to name a system, like you'll almost always have the Earth as part of the system. So make sure you write that. And then other parts. So what part of the system is what creating or experiencing the energy? So just know that. And then, like I mentioned before, just know how to set up the LL diagrams and you should be good. All right. So you're gonna have until Sunday night to work on it, but I'm gonna give you starting Thursday, March 26th to start on it. By then, these solutions should be uploaded, so you can take a look at them. look through these lessons, look through these solutions before taking a quiz, because you will have a time limit. So you won't have enough time to just look back at your notes. Make sure you know how to do it beforehand. All right. Thank you, everyone, and I hope you do well in the quiz.